everyone, my name is Taylor Smith, aka the Career Coach, and today I'm talking about what do engineers do. So if you've ever wondered what exactly does an engineer do besides just design work, then this video is 100% dedicated to you. We're going to talk all about that. We're going to talk more about some of the different jargon and terms that engineers use so that you can get a better, full understanding of what they do on a technical basis. Alright, so first and foremost, we're going to talk about literature review and research. So this is one of the first things an engineer does whenever they're creating some kind of new design, some kind of new process, what have you. So normally what they'll do, they'll complete some kind of literature review, which is basically some research on some scholarly articles that already exist within the world or within that industry, etc. So they're going to look at all of this research completed by other people and get a good feel and understanding of some of the things that people have already done in the past that's available and viewable for any kind of person to see, or they're also going to see what kind of process have people attempted but may have not been successful in. So they're going to review all of this information. They're also going to do some more research about just general principles and practices, and also collect some information as far as different formulas that they may be able to apply. Some engineers, they may even go a step further. This may be where you become more of an inventor. They may go and create some of their own formulas, but usually you'll kind of use what kind of already exists, and then you'll apply it to your own practices and the things that you want to use. So based off of all this information that's collected, now you can start doing some kind of calculations based off of the things that you want for a specific design. And then you may also do a little bit of initial testing, or maybe anything in the lab as far as lab testing, depending on what kind of process or what kind of product it is that you're looking to attempt to make. Up next is design. So now that an engineer has collected all the information that they need in order to make the decisions that they want to make in order to create a specific product or process, they're going to start some kind of design work. So they're going to apply all the calculations, all the information that they already formulated, they've written down, they've collected, and they're going to start designing some kind of program, process, or product. And so they're going to use a lot of different modern day tools instead of having to always do everything by hand like they may have done decades ago. And so a lot of these programs are of course going to vary per engineering discipline, but this could be like AutoCAD or SolidWorks for mechanical engineering. This could be Aspen HYSYS programs for chemical engineering. If you are doing some kind of computer programming or code, this could be anything within C#, C++, Python, Java, the list really goes on and on. And so basically what the engineers are doing, they're using these different systems so that they can start coding if you're within the computer space, or they're doing some kind of design work to say, okay, I want this to specifically look like this. I want to add this specific unit. If it's some kind of chemical process, I want to add this angle, I want to add this element, etc., etc. And during this phase, they're also doing some material selection as well. So while they're doing this design, they need to keep in mind the different materials that they're going to use in order to implement this process, especially for a mechanical, electrical, and chemical engineer. So they need to consider what are they going to use specifically within the product, or if there's anything else that's used to create the products, for example, some kind of chemical process, then you want to make sure that the pipes and the different reactors and units that the chemicals are going to touch aren't going to corrode or create some chemical reaction that could result in a combustion or other just very dangerous factors. So you want to make sure you're including all of that in the design work. They may also be selecting specific temperatures and pressures so that their system and process can run very smoothly, but just a lot of very technical things during this design process. In addition to the material selection, they're also going to create something that's called a BOM, or a bill of material. And BOM is BOM, right, for bill of material. And basically this is just an outline of everything that they're going to need in order to create this product, this process, what have you. And so you can think of it kind of like a recipe, right? You have your list of ingredients. This is what the list of ingredients are, is this bill of material. And the final design is the final product, or baked good, or food meal, whatever you're going to have at the end of the day. And so the engineer is basically creating this ingredient list up front while they're creating the design and kind of figuring a little bit about the recipe of what the final product will be. During this stage, it's also very important that the engineer identify any potential risks. So they're going to complete something called risk assessments to make sure they identify all potential failure modes, all potential risks that could impact the environment, that could impact the design, different features, different capabilities, every single combination that you can think of. And they're completing these risk assessments to making sure that all the decisions that they've made within this design make sense, and it's going to have the least impact on hurting anything or anyone. So it's really extremely important they complete this, any hazard analysis, any similar things like that, to make sure that they have the safest and most reliable design as possible. Alrighty, so up next is simulation testing. So I'm also going to group in prototypes in this section as well. So it really just depends on the type of engineering discipline that you're involved in. But basically at this step, the engineer is practicing and applying what they've already designed and putting it in a real life scenario. So if this is some kind of chemical design or process, they're going to undergo this simulation, which is basically something that's theoretical on the computer and just making sure that everything would run smoothly in a perfect world with all the different temperatures and pressures applied, and if it actually runs smoothly throughout the entire process. If you're some kind of mechanical engineer, you're going to do some simulations online as well, but also you're going to actually physically build the product. You're going to create some kind of prototype, and you're going to make sure that everything actually assembles well together, everything functions and moves the ways that it's supposed to. Also with electrical and computer engineering, you guys are doing very similar things as well. You're testing your circuits, you're testing your code, and making sure that it actually runs like it's supposed to, and all the sensors, all the features, all the signals, all the codes, every single thing that is supposed to work is actually working, and nothing is failing, nothing is going unaccording to plan. Just to reiterate, this step is extremely important because you need to validate that the process or the product actually works before you do the mass production of this product. So if you want to learn more about what the mass production is exactly, as far as when you go from the engineering prototype or the design to the full implementation, where we're creating a mass production and we're pushing out all of these products or these services for the end customer, then you want to make sure that you stay tuned for next week's video, where I'm going to talk all about that in the engineering model and how that relates to the initial customer's need, going through sales, and everything else that follows after that. So make sure that you guys subscribe and hit the notification bell so that you don't miss that video and you can learn all about the engineering model and so much more. Alrighty, so next we have dispositions and troubleshooting. So let's say during the manufacturing process, after we did the prototype, everything's gone through and we're now doing this mass production. Let's say that we have one of our machinists or one of our technicians who's currently servicing or currently creating this final product or process, and there's some kind of error, there's some kind of glitch, there's some kind of defect of some sort. Then the engineer will have to create some kind of disposition. So basically they will look at whatever the error or the problem was, and they'll have to identify it, and they'll have to understand and see how does this affect different processes and implementations for the final design of the product. Is it going to affect these different key performance indicators that we need the product or the process to perform on specifically, or is this going to affect some of the final compositions at the end of the final chemical process, what have you. And so what the engineer is going to do, they're going to process this information, and they're going to maybe do some tests and trials to see how it affects the process, or they may already know these things up front, because while the engineers are designing, they are supposed to create different tolerances, which are basically allowable deviations from the exact measurement, especially for mechanical design, to determine that you can still stay within this tolerance or this threshold and still be okay. But if something falls outside the tolerance lines, whether it's for a chemical process or some kind of mechanical process, then the engineer must look closely at it and make sure it doesn't affect the design in any capacity. If possible, you can also do some kind of rework. So the engineer will usually look at that. Usually if you do not go on an oversize, let's say you're cutting some kind of piece of metal or material, if you cut too much, then you're not going to be able to save the final product that you created. However, if you cut just you didn't cut enough, let's say, then you can keep cutting so that you can get to the perfect size that you need to. It may be really close because you're really close to the dimension, and if you keep cutting, you may potentially risk going oversized. But these are some of the decisions that the engineer will make in order to get back to the manufacturing team, and they will also work together to determine what makes the most sense. And worst case scenario, if something doesn't work, then there will have to be some kind of scrap. So that means that the product or that component, that piece, isn't going to be acceptable, and so what they'll have to do is start over from scratch by creating some kind of new component, whether that's an overall product, whatever. But when possible, you do want to try to avoid scrap, because obviously that can add up to a lot of different money, which it would affect different quality metrics and money that the company has to absorb, that of course you're not going to charge to the customer, right, because it's your own defect or fault within the manufacturing process. However, you want to make sure that you are applying the processes smoothly, and that's why it's so important that the engineer does all the application testing and validation beforehand to make sure that everything from design actually makes sense in practical use, because sometimes things on paper doesn't always make sense in real life, and the more you can foolproof it and make sure that it's a clean and smooth process, the more likely to have less errors during the manufacturing process. However, in a few weeks I will have some more videos where I talk about supply chain and manufacturing processes and how people within the operations and supply chain can actually work towards improving processes to make them cleaner, make them leaner, make them a lot more simple and less likely to have different errors and scrap values like this. And so we'll discuss this a lot more. In addition to this, I do want to elaborate more on troubleshooting. So maybe this is some kind of code or some kind of process that a computer engineer may have made, or computer scientist, and there is some kind of failure, there's something that's not exactly working. What they're going to do is troubleshoot the process to identify what are some of the failure modes so that they can correct it and resolve the problem. Similarly, after the product is finally made and is sent out to the field, the final customer, whether it's in the field or whatever practical use it's being used for, if there's any kind of errors or glitches, any kind of failures, the same thing is going to happen here, where the engineer is going to identify what are the reasons for the failure modes where it's not allowing it to hit the performance targets that it's supposed to hit, or maybe it's just not working at all. They're going to identify all of these different things by completing some troubleshooting test runs in order to identify the problem and overall resolve it. Alrighty, so up next is data and analytics. So whether this is during the product's use or after it is completely used and the life cycle is done, engineers love to collect this data and analyze it to really see what happened, what may have went wrong, what went successful, etc. So they're analyzing this data so that they can pocket it and they can use it and apply it for future foreseeable products they may create that are very similar and maybe even very different. So they want to see what kind of went wrong with any failure modes or any turn-offs, anything that they may have also collected during the troubleshooting phase as well. They also want to see what metrics they have on how well did the product run, for how long, and then also what was the total life cycle on the product. So was it able to last as long as they anticipated, or did it not last as long as they thought? And they're able to collect all this data in order to create better and better products in the future. Some key things that the engineers may want to look out for are how well did the product perform compared to the key performance indicators that they identified at the very beginning of their design process and that the customers asked for, and also what is the reliability of the product. Is it actually something that lasts long and is very durable and is able to withstand long periods of time, or is it something that's kind of brittle, that's not really working, that's falling apart and definitely needs a whole new redesign? And another big thing that engineers may work on is related to root cause analysis. So this is pretty similar to some of the things that we talked about before, but if there's any major failure modes on a specific product and it's just not working at all, then the engineer wants to complete this root cause analysis to really understand what went wrong with the process, what were the key things that caused this problem, whether it's related to the actual product and other variables within it that may have caused this, or maybe earlier signs that showed that it was about to fail, or maybe it's some kind of outside circumstance or external variable that may have affected the product and created this failure, whether it may be some kind of water, some kind of environmental factor or what have you that really led to the collapse or the failure mode of a specific product. And doing this analysis, the engineer is going to be able to identify what are some target areas that may need to have some room for improvement, or how can we prevent this problem in future so that we don't have similar failures like this, and how can we get the product up and running again immediately, or if we need to, maybe we need to create a whole new product or give them some kind of replacement product, and they just have to make sure that they prevent any of those circumstances from happening again. Alrighty y'all, well that's it for this video. I hope that you guys liked it and you learned something new. If you did, make sure to like and subscribe to the channel. If you want to learn more things about engineering, models, engineering in general, engineering career paths, all that good stuff, make sure to check out the other things on my channel, as well as anything else related to career readiness as far as getting your career started with a new job, related to resumes, elevator pitches, and so much more. Until then, I will talk to you guys soon, and take care. I'll put all my social information in the description box, but I will talk to you guys soon. Bye.